All right, so let's go ahead and go through practice problem 1. So problem 1 is using this crazy graph of g of x, and we're asked to evaluate a ton of limits. So in part A, we are looking at the limit as x approaches 0 of g of x. So we want to look, and notice it doesn't say from the left or from the right, so we need to do both. So we want to look on our function from the left and from the right and determine what value are we approaching when x gets closer to 0. And we see that that value is 2. Next, we want to look at the limit as x approaches -1 of g of x. So we're going to go ahead and trace from the left and from the right. So from the left as we approach -1, and from the right as we approach -1, notice what's happening, right? If you zoom in, you can see pretty clearly that from the left-hand side, we're approaching 2, and from the right-hand side, we're approaching 4. And we discussed in the notes that if that's the case, if our left and our right-hand limit don't match up, we get that the limit does not exist. Okay? So in C, we have a little bit of a different situation. If you'll notice, there is that negative symbol up above. And recall that this means we want to see x goes to -1 from the left. Okay, so here we only care about that one side. We're only going to look at the behavior of g of x as x is going towards -1 from the left. So let's go ahead and check out our graph. Looking at that, right, looking from the left-hand side, approaching -1, we see that our function is approaching that value of 2. So down here, our answer to part C should be the limit as x approaches -1 from the left of g of x is 2. Oops. All right. In D, notice we have again a little bit of a different notation. Here we're asking what happens as x goes to -1 from the right. Where is our function going? So again, we're looking at these two sides separately, maybe to support the fact that we saw that it didn't exist. Maybe we'll see something interesting. So looking back at our function, if we trace g of x from the right of -1, we see that it's actually going all the way up here to +4. Okay, so the limit as x approaches -1 from the right of g of x is +4. Okay, and just like I was kind of hinting at, we see that the left and the right hand limit do not agree, right? So we have that the limit as x approaches -1 from the left of g of x, we have that that is not equal to the limit as x approaches -1 from the right of g of x. What that means is this. It means that the limit as x approaches -1 in general of g of x does not exist. Okay. All right. Part E says, well, what is the value of g of -1? So what that means is we have to decide when x equals -1, what is g of x? Okay, so we're going to go ahead and look closely at our graph here. We're going to see the value, the x value of -1. Notice if we go up here, we have a hole. We go up further, we still have a hole. We don't have definition of our function until that value of x equals 6. So what that lets us say is that g of -1 is +6. Okay. Moving on to f, it looks like we are deciding or trying to determine what the value of our function is, or what the behavior of our function is, sorry. Where is our function going as we approach x is 4 from the left. Okay, so again, I think it's worth noting, just while we're getting comfortable with this, that we're looking at x goes to 4 from the left. Okay, so let's go ahead and peek at our graph. We are seeing on our graph that from the left, x goes to 4, right? We're cruising up to x is 4, and we see that the behavior of our graph is 3. As x is getting closer to 4, the graph is getting closer to 3. Okay, so the behavior of our graph at that, to evaluate that limit, is 3. All right, we'll go ahead and look at part G, noticing that that is a certain notation as well, reminding that this is saying that we're looking for the behavior of g of x as x goes to 4 from the right. So looking back at our graph, we're going to trace g of x from the right of 4, and we're going to see that as x is approaching 4 from the right, our function is approaching 5. Okay, so that allows us to make the claim that the limit as x approaches 4 from the right of g of x is 5. Oops, that's not super helpful. Is 5. Okay. So, like we saw earlier, what this tells us is that the limit as x approaches 4 of g of x has to be undefined. So when we look back at the graph, we saw that from either side of 4, when we approached from the left and when we approached from the right, we were getting two very different behaviors, right? As we approached x from as if we approached x is 4 from the left, we got the behavior of 3. And when we approached x is 4 from the right, we got the behavior of 5. So because the limit as x approaches 4 from the left of g of x does not equal the limit as x approaches 4 from the right, we can say that the limit as x approaches 4 in general does not exist.